Hopefully you see that in full screen. So welcome everyone to the interest group session from the Physical Samples and Collections group. Our session's name this time is Cross-Disciplinary Sharing of Samples and Increasing Awareness. And this session is being led by our co-chairs, Kirsten Lennart, Leslie Weiborn, myself, Esther Plomp, and Jens Klump, who will join a little bit later. So just as an intro, the session is being recorded. So if you do not want to be recorded, you can contribute in chat and through the Google Doc that I linked in the chat. And so please also mute yourself when you're not speaking so that we don't have any interruptions. And you can fill in your attendance or your name, affiliation, your contact details in the session document. Which I'll link again once I close down the presentation because I can't actually see anything right now. And again, if you have any questions, please, you can, if you want to, you can unmute, of course, but do note that you're being recorded. And if you don't want to be recorded, you can use the chat. And if you want to leave an anonymous comment, you can also use the Google Doc, of course, for that. Then I'll hand it over to Kirsten to introduce the interest group.
Yeah, warm welcome from me as well to everybody who is attending. I think we're still having people come in. Yeah, I've been in this interest group since its start. The reason we established this group is that we recognize the relevance, the value of physical samples, physical objects in the research ecosystem, and that samples need to be in many ways integrated into the data ecosystem that we're all dealing with, and need to be as findable, accessible, interoperable, and reusable as data are. For that to happen, we need to work on shared practices, standards, and policies on an interdisciplinary level. And that's, we recognize that there were lots of efforts going on within individual disciplines, be it the geosciences, the biosciences, and so on, but there was a lack of communication and coordination across these disciplines. So the interest group really formed to focus on topics such as persistent identifiers, metadata, and the vocabularies used for these metadata, how to register samples, discover them through catalogs, making metadata available through all kinds of mechanisms for harvesting. But also it comes down to topics of the actual objects preservation policies and so on, and the related physical infrastructure for sample preservation and access, which are still quite challenging topics in our community. Next slide, please, Esther. So as you can see here, the group has really been active. We have met at every plenary since the group was formed in 2017 at the Plenary 10 in Montreal. It's been, a lot of focus on the multidisciplinary aspects, on metadata, identifying common vocabularies, common metadata schemas, and so on. And I think we're going to continue for a while still and discussing establishment of working groups and so on to make progress on these different topics. So next slide. So for today, our objectives and goals are to provide a forum for all kinds of initiatives that have been going on, but that are also emerging as new collaborations and new activities that are related to physical samples. And we have indeed seen a substantial increase of activities and a much broader participation aspect of physical collections, physical samples over the last couple of years, with major projects worldwide being funded to help physical samples become more accessible and part of a fair research data ecosystem. So again, we're focusing on converging on a shared vision and strategy for advancing fair samples, advancing accessibility, interoperability, and reusability of material samples. And again, multidisciplinary across domains. So it does not only pertain to samples in the natural sciences, but we're thinking very broadly into domains of material sciences, of medical sciences, and so on. So we really encourage participation in this interest group across all domains that deal with physical specimens, samples, and objects. And I think with that, I'm handing back to Esther to introduce the agenda. And I wish everybody a great meeting, and please participate as actively as you feel or as you can. So Esther, take it away.
Thank you. So for today, we're in the middle of the welcome, and that will be followed by a presentation by Joël Ben, which I'm hoping that I'm pronouncing correctly, sorry if not, on a national cross-discipline service for physical sample identifiers. This talk will be followed by a short Q&A. Then we have a talk by Anita Bondrowski, who is unfortunately probably not present in the session as we speak, because it's 3 a.m. For her. So we have a recording of her talk. Then we would like to discuss an infographic or an FAQ flyer that can increase awareness of the importance of physical samples and their management, and what you should do with physical sample data. This idea was raised by Maggie Hellstrom in the previous plenary, so we decided to pick this up, and we have a draft available for you to comment on, and of course to contribute to after the plenary. And then we have an idea to hold a webinar series, which I will shortly introduce. And Rory McNeil from RSpace, who has already agreed to do one of these webinar sessions, will shortly introduce their topic. And after that, we're already at the end of the session, and we'll discuss next steps. And so we're looking forward to hear from you there as well. So we first start with the talk from Joël Ben. I'm going to hopefully stop sharing my screen so that you are able to do so. Let's see, this is very disorienting. I'm using two browsers. Okay, now I can finally see people again. Are you able to share your screen?
Can you see my screen?
Yes, perfect.
You can see the slides okay? Because I can't see them, so I'm hoping they're up.
Yeah, we can see them. I think I need to turn my video off so that we can see them better. Hopefully. Oh, okay. So if everyone, you can click the expand screen button at the right below corner of the slides if you haven't done so. And that should hopefully provide you with a better view of the slides if you need that. Okay, please take it away, Joël.
Great, thanks Esther. So hello everybody, my name is Joël Ben. I'm a DevOps manager for the Australian Research Data Commons. And today I'm just going to talk a little bit about an approach we've taken to a cross-discipline service for physical samples, in particular IGSN. So I'll start with the acknowledgement of country. So we'd like to acknowledge and celebrate the first Australians on whose traditional lands some of us meet, and we'd like to pay our respect to the elders past and present. Now, for those on the call that don't know the Australian Research Data Commons, it's basically a government-funded initiative. It's a transformational initiative that enables Australian research community and industry access to nationally significant leading-edge data-intensive e-infrastructure, platform skills and collections of high-quality data. And basically, the ARDC recognises that persistent identifiers are a core component for national infrastructure and to key world-class global research infrastructure. And we offer several PID services. So we have IGSN, DOIs, RAIDs, and also a handles service. And there's a link in the slides to our basically a policy around our persistent identifiers in terms of the organisation. Once they're distributed, you can have a look at that in your own time. In terms of providing a little bit of a context around the ARDC IGSN service, so in 2018, the ARDC stood up its initial IGSN service, and it was a collaboration between the ARDC, Auscope, which is a research facility in Australia, and also the Commonwealth Scientific and Industrial Research Organisation, CSIRO. And the service was basically implemented as part of a Geosciences Data Enhanced Virtual Laboratory project, which was an ARDC funded project. And the project was proposing to implement an IGSN service basically for the earth sciences community. And ARD saw this as an opportunity to scale it into a national infrastructure offering. Now, in order to get the IGSN service up and operational for the project, we basically adopted some software that was introduced or developed by CSIRO. And that allowed us to really expedite the install of the service for the project. But the eventual intention was that we would scale this up to be multidiscipline. Now, once we'd installed the software, the adopted software, and it was up and running for the project's requirements, we discovered that there was obviously quite a few limitations that the ARDC would need to address in order to get it to a sort of a national scale service that was cutting across discipline. So I guess the three that I'll highlight here, so we don't take up too much time, is that the adopted software was tightly coupled to a single schema for earth sciences and a single vocabulary that was hard-coded into the schema itself. So this was going to make it really difficult for us to expand out to other communities and disciplines. We would either have to stand up separate instances and basically tweak them individually, or that whatever disciplines came on board would have to try and squeeze their information into the current metadata schema. The software was unable to be configured to use multiple IGSN metadata store accounts, which was a bit of a showstopper for us in the way that we organize our accounts, and I'll go into that in a little bit later. And it was also limited in that anybody that was using the API to mint IGSNs, they couldn't use the web interface to modify those. The API functionality was really limited in that it had a single mint endpoint, and that was pretty much it. So if you were looking to update your metadata for an IGSN, you would also call the mint endpoint, and that was pretty confusing for our end users. So in terms of the options we saw we had, we could continue to develop the CSIRO software, and with its tight coupling to the schema, we thought this was probably a very difficult path to go down. So we scrapped that idea. We did a somewhat environmental scan of open source solutions to see if we could find anything that we could reuse and sort of adapt to our needs. But a lot of what we found was sort of dated technology, and that the developers and engineers didn't feel overly comfortable with adopting something to customize. So the final option was to develop in-house. Now, we certainly weren't starting from scratch when we were developing in-house. So we obviously had the experiences with the existing software that we'd adopted from CSIRO for IGSN. We also operate several other PID services, which I explained before. And we also, the team that was going to be developing the software has 10 plus years experience in developing a metadata registry that sits behind our National Data Discovery Service, which is Research Data Australia. It's an image on the page at the moment. So over the years, we've identified sort of traps and things that we'd really avoid in the next sort of iteration of our services. So some of these include sort of being able to support multiple formats and schemas wherever possible, making sure that we can store the original content that's provided from our clients, because obviously transforming from one schema to another is generally a lossy process. And what we do with RDA is we basically squeeze everything we're provided into a single schema, and that's quite a lossy process. We wanted to ensure that requests can be restarted or reprocessed in the event of an outage or a problem during processing. And we've identified that any sort of non-critical, non-time critical paths can really be broken out and put in the background, so clients don't need to wait for those to finish. So that's what we've also done in the new system. And also dealing with so many schemas over the years, we've found that they pretty much all have common elements that we can use to address some of the key use cases in our services. So for example, in RDA, which the key use cases around discovery and access, a lot of the information we can get from all the schemas that we are providing. We don't necessarily have to convert them into a single schema. So our plan, we were going to develop an extensible and reusable metadata registry that supported multiple metadata schemas from multiple disciplines. We wanted to support the creation and management of persistent identifiers via international PID services. So we didn't want to just limit this to IGSM. We wanted to be able to use it for things like RAID and DOIs, etc. We wanted to provide both web and API interfaces for the creation and management of resources. And we wanted to expose any public content via the OAI protocol for downstream service providers to be able to harvest from us. We also wanted to expose schema.org metadata in our landing pages for IGSN, and this is sort of tailing on to the end of the IGSN sprint that happened, I think it was last year or the year before. And as I said, we wanted to be extendable and reusable, so we wanted to be able to possibly use this in the future for, say, RDA and other services. So what did we come up with? Basically, we came up with a service which is comprised of 4 main components. So we have a registry component, which is really the backbone of the service. So this is pretty much the persistence layer. It provides all the APIs for interacting with the registry, and it provides all the IGSN services as well. We have a portal which displays the metadata in a web interface, and it acts as the default landing page for any IGSNs in the system if the clients choose to use it. There's an IGSN editor, which is a web interface that allows authenticated and authorized users to create and modify IGSN resources. And we also have implemented KeyCloak, which is an open source identity and access management solution, which provides all our authentication and authorization between all the components in the system. So the features that we included, I won't go through all of these. I'll just highlight a few of them. So we've incorporated multi-schema, multi-format support, so we can pretty much configure the system to accept any serialization format and any schema from any discipline, which is going to be really handy going forward. We've got metadata versioning, which is completely new and allows us to have a complete history trail of a resource over time. I've obviously got the UIs and the APIs for the creation and management of IGSNs. And we've put in some bulk minting functionality, and this was one of the requests we got from our clients that wanted to do sort of retrospective IGSN minting. They had databases or spreadsheets, and they wanted to be able to put thousands through at a time. And we've also included a reservation, sort of a reserving endpoint, which would allow, say, expeditions that are going out to do sample collections. They can basically reserve a whole heap of IGSNs before they go out, and they can actually assign them in the field as they make the collections and the samples. We've also introduced stateful request management, which I'll cover in a little bit. And we have the notion of sort of group and user ownership, which allows users to mint their own IGSNs that are private for them only. And then also a group, so users can manage IGSNs on behalf of a group and share them between members of the group. The technology behind the service, the registry itself is primarily a Java Spring boot application. We use Vue.js for all the web interfaces, MySQL for sort of persistence, and then as I spoke about, we've got KeyCloak embedded as well. So is the service schema agnostic? Not really. I think being schema agnostic is extremely difficult, especially when you're sort of cutting across multiple disciplines. So what we'd like to call it is sort of schema configurable or schema flexible. So basically the registry component can be configured, as I said, to accept any format and schema. The content that we're provided by the clients that are minting an IGSN or creating a resource is stored and not transformed into a single schema. So we're not losing any information, and we have the richest information possible to either develop service on top of or pass down to third-party service providers. We're only extracting the minimum metadata that's required for the service to operate. So that's things like titles, the status, the visibility of the IGSN resource, etc. And another thing that we've brought in with the sort of versioning of resources is that we can basically store multiple representations of a single version for a resource. So in our service, when you mint an IGSN, we actually create a few different representations of the metadata. We create one for the IGSN MDS system that we send up to the MDS global system. We create a DC version of the content for our OAI PMH service. And we also create a JSON LD content, which is downloadable, and also we can embed into our landing pages. Now, the last point there around the portal and the editor UIs, these are schema specific, so they're tied to a specific schema. So if new schemas come on board, we would basically have to create a new portal interface or a new web form basically to support the schema and its elements. In terms of how the schema configuration works, so if we get a new discipline on board, basically there's a JSON configuration file which allows you to define new schemas. It might be a little bit hard to see, but the example I've got up here, there are a few key things that you add to describe the schema. So we give it an ID, which allows it to be identified throughout the system. And when clients make requests for specific payloads, they can pass that ID. But the three main sections that are configured are we have a validation section, a transform section, and a providers section. And these basically identify what happens when a request is made with a certain content or payload type. So the validation section basically describes how you would identify a payload type and how we would validate it as it's ingested. So the example I have here is an XML validation. So we're basically pointing to the namespace, which allows us to identify the content that's coming in. And then we have a schema location and a local schema location. The local schema location is used for optimization. So we store a cached copy of the schema, and it just makes the whole lot a bit faster. The transformation side is what I spoke about before. So as a payload comes in, we actually generate multiple representations of that version of the payload. And that could extend to any number of things. So we could have different schemas between disciplines being transformed so that they can be offered down to third-party providers, service providers. The example I have here is the three I spoke about. So we have three simple Java classes that basically take the payload coming in, converts one to a JSON LD, one to a representation of the metadata that gets sent up to the global MDS system, and also one that converts it into a DC Dublin core representation for OAI. The providers itself, basically, they're simple. When I was talking about before with the minimum information that we're extracting to allow the registry and the system to run, the providers are how you would pull that information out of a payload. So basically, each of the items that are defined here are pointing off to simple Java classes that basically know how to get that bit of information out of the metadata that's being provided. In terms of the requests in the system, so we have the notion of single requests and batch requests. Single requests process synchronously and they respond to the client really quickly. But if they're large batch requests, we process them in a queue. The validation process will actually take into account if there are queued tasks. The single request will actually check the queue to see if there's anything that's already been requested, basically. So if someone's already requested an IGSN and then a single request comes in to mint the same IGSN, it will basically pick that up and respond with an error. Now, the stateful request management, which is pretty important throughout the system, and there's a bit of a sort of in the graphic down the bottom, a very general overview of the process. But basically, when a request comes into the system, we store everything we can possible about that request. So if something goes wrong in sort of the pipeline process, we can restart it at any stage without needing the client to basically make the request again. We've also introduced background processing for the MDS or IGSN MDS global system. So this means that when a request comes in, we can do all the validation and process, respond to the client really quickly. And they don't need to worry too much about the process happening in the background for any updates or minting at the IGSN MDS service. We can give them a link that basically they can use to poll us. So if it is a batch process of thousands of IGSNs, they can poll this endpoint and basically see the status and summary of their requests. Very briefly, just on the access and account structure, as I said before, the AIDC operates generally with its services in a sort of organizational structure. So we don't allocate service access directly to a user to mint their own IGSNs. We set up an organization within our systems. So for example, we would set up, say, CSIRO as an organization. We would allocate them a sub namespace for IGSN. And then we would also give them a single MDS IGSN account for them to use. So all their IGSNs would be minted underneath that one account. The users that then belong to that organization, they'll get an IGSN role, and they can create and manage IGSNs. As part of that organization, they can set them to private, so only they can view them and manage them, or as the organization, which every member in that organization will be able to manage the IGSNs. The other thing to highlight is just that through the using Keycloak, it comes with sort of SAML, OAuth 2, etc. And so we get all the benefits of being able to plug in with sort of third-party providers such as the Australian Access Federation. We can use ORCID accounts and things to log in and start creating IGSNs. In terms of the interfaces, so the web UIs, we have a dashboard which allows our clients to log in. They can view all the IGSNs that have been minted either by them or members of the groups that they belong to. They can search and discover when they were updated. We have an add and edit form, which allows people to manually create resources or IGSN metadata. And I guess the benefit of using the interface is that you don't need to necessarily understand the underlying schema. It also has a lot of in-context help to enable really rich metadata descriptions. And we also provide a lot of widgets which allow sort of, again, those rich connections between the sample metadata. So the example I have here on the page is, on the right-hand side of the page here is an ORCID widget, which allows the person entering the metadata to do a search in the ORCID registry, and it'll actually pull back the information about that researcher and pre-populate the fields. We also provide a map widget, which is just a quick and easy way of defining spatial regions for the resource, excuse me, without copying and pasting from Google or manually typing it in. We have what's called the portal. It's not necessarily a discovery portal at this stage. It's more our landing pages for the IGSNs. So these are automatically defaulted to the portal pages unless a client overrides it with their own URL associated with their IGSN. But it provides, a QR code to resolve. You can download the metadata. You can download the JSON LD, and obviously it's a nice representation of the resource for somebody to come to and discover. We also have APIs, so we have both remote procedure call APIs and REST API endpoints for managing the IGSNs and interacting with the service. And we also have sort of Swagger interactive documentation for all our APIs. So once you get a test or production account, you can come in and sort of kick the tires a little bit and explore the service before you start integrating. In terms of where we're going in the future, we'd like to break up the source code a little bit more, just so it's more extensible for both ourselves and for reusers of the software. We want to get it out onto GitHub sort of as quickly as possible, but we're sort of aiming for November this year. We're in the early stage of exploring integrating Neo4j to manage relationships between the different resources, and that's what we currently have sitting behind Research Data Australia. We're integrating Elasticsearch to support searching in the web UI, and also for the next dot point is providing a search API. So we have a really interesting use case from one of our clients who wants to be able to search in specific regions for existing or IGSNs so that they don't actually duplicate and mint another IGSN for the same sample. So that's a pretty interesting use case. We also want to have a link checker just so that we can check all the links associated with the IGSNs so that they continue to resolve and we can report back to our clients. And we want to improve the test coverage overall for the service, primarily before we go open source. In terms of contact point, services at ardc.edu.au is the best point of call. And then they can sort of send you off to the appropriate people or team within ARDC. We do have some documentation at documentation.ardc.edu.au. It's primarily geared towards our clients, but there's still some useful information in there. And if you're more interested in the technical side of things, feel free to drop us an email and we can provide you with some information. And that's it.
Thanks so much, Joel. This is absolutely fantastic. As a reminder for everyone attending the session, if you have any questions, put them in the chat or in the Google Doc. And while people are still doing that, I have some questions, if I may. You said that the code will be available on GitHub and by the end of this year. Is there perhaps already a repository that we can start or follow, or something to keep updated on that?
Not at the moment. So we have an internal Bitbucket server, and that's what we use for most of our private stuff. So the idea behind it is we've actually got another internal project working on the same source code at the moment. So we just want to make sure that we've split that appropriately for people to be able to fork and extend before we make it live on GitHub.
Fair enough. Thanks so much. And a follow-up question on that is, it's great that that will be available, but how easy would it be for other initiatives or institutes to implement this for themselves? Because not everyone, of course, has a team of developers. Could you comment on that?
Yeah, absolutely. I mean, overall, it's pretty lightweight. We've made it as reusable as possible. So we've really broken it down into smaller components that people can pick and choose from. So as I said, the backbone is really the metadata registry, and then people can put their own flavor of portals and APIs on top of that if they like. I think the key point to make at the moment is that the only access management side of things that we've got working at the moment is Keycloak. So you would have to basically stand up Keycloak, which is pretty easy to do as well. We have left some hooks to do sort of built-in logins in the database, but we didn't get that far in the time frame that we had.
Okay, thanks so much. I'm going to give someone else an opportunity to ask a question. You can also unmute and ask your question directly. I think Kirsten is going to.
Esther, there's a question in the question and answers for Joel.
That's why I missed it. Sorry. I was looking at the chat. Sorry, Mary. Mary is asking, with the intention for this work to be used beyond the earth science community, will the identifiers continue to be IGSN, or will a more generic identifier be coined?
Yeah, it's a good question. I mean, if we're talking about samples and specimens, then definitely it would be an IGSN. That's what we're supporting out of the box. If there were other identifier types that the communities needed, then the software would definitely be able to be adapted to those. We'll probably look in the future at using it for both our handle and RAID service going forward. Yep.
Wonderful. I hope that's answered the question, Mary. And I don't see any other questions in the Q&A or the Google Doc. So I would like to thank you very much for this presentation. It was really great. We can't. Oh, Jens, do you have a question?
Just a short addition to Joel's answer. The name IGSN might be a bit misleading because historically it refers to geo, but the intention is that it will be a generic identifier. So don't get fooled by the name. It's for any physical object from the universe.
Thanks. That was really what I was getting at, was would the geo tag in there actually put other disciplines off feeling that it wasn't really an identifier for their samples? Or would you intend to drop the geo to make it ISNs possibly?
Well, we are discussing this at the moment because IGSN is an established brand. So one of the ideas was to just define it as a recursive acronym and say it's the IGSN global identifier or generic identifier or something like that. But I get your point is certainly an important one, that we are discussing how we remedy that without losing our brand name.
There's a lot of creep that happens in academic research, and systems that develop for one thing specifically then get widened out to be used for a lot of other things, and they don't always, obviously the work you're doing really is widening it out, but they often don't reflect really the new disciplines that they've expanded into. So yeah, it's just being aware of that, I think.
Yes, definitely. Thank you.
Thanks so much also, Jens, for jumping in there. Okay. If there's really no further comments, remarks, questions, we should really move on to Anita's presentation. So thank you very much, Joel. Sorry about the non-applause. I'm just going to do a silent one. You have lots of likes and hearts. Yeah, there's indeed not an applause button, but the like and the hearts are being pressed. So thanks again. And then we'll move on to Anita's presentation, which is on YouTube, and hopefully I'll first, yes, hopefully you can see the screen and can also hear it.
Okay, here we go. Hi, my name is Dr. Anita Bandrowski, and I will be talking to you today about research resource identifiers. And it's about primarily about identifying key, mostly biological resources. Thank you. Okay, So looking at what an RRID is, it is essentially a syntax pattern for referencing reagents, things like antibodies. It's a lot like a CAS number, but it is certainly for a lot more of the squishy biological stuff that CAS doesn't really cover. And it's somewhat similar to the IGSN. So the RID syntax, this is the full syntax, which really covers the company or the provider. So in this case, the Developmental Studies Hybridoma Bank, DSHB. There's a local identifier. This is usually a catalog number. The version or the lot of the reagent used, and then the global persistent unique identifier. So this is the RRID component of this, right? If we examine this a little bit more closely, the syntax pattern of this global unique identifier really actually says the following. RRID just says essentially, hey, I used this thing. And the authority or the data source where this information came from is kind of listed in the next component of this. And then that is just a short name of the authority. And then the identifier from that authority is the next portion. So again, somewhat similar to the IGSN. Okay, who are these authorities for biological things? Well, they're people like the MMRRC, and I'll come back to this in a few slides. This is a mouse repository. There are obviously flies, pigs. Abgene has little snippets of DNA. Biosamples, mostly tissue samples. Cellosaurus here has cell lines, and the antibody registry is responsible for antibodies. And so all of these are the authorities, and then their data gets filtered down and gets put into a particular portal called the RRID portal, which makes all of these items fully searchable within a single place. Then authors can be directed to that single place to go and get their RRID numbers. And this actually does happen. I'll show you how that happens by the journals. So the journals have instructions to authors that say, hey, go get your RRIDs. Here's where you go. Now, what else is in the RRID portal is a bunch of statements about some of these individual RRIDs. And so the literature itself can reference a particular item, and it can say something like, this is good, this is bad, this is contaminated. And there are a lot of projects like core facilities, international projects that also will say things about some of these different reagents. Okay, so all of that, again, is put into a single portal, which somebody can go in, they can type in their query and get a list of the matching reagents. Okay, but does it work? Does it work to actually increase at least the ability for somebody else to come in and find those reagents? Well, we did a 3-month pilot project. We're still going. This is now our 7th year with 25 journals. And we found out that essentially without RRIDs, authors are fairly poor at actually identifying the resources that they used. But with RRIDs, they're much, much better. So in this bar graph, we're just looking at the identifiability of these reagents. And so for antibodies here, in the issue of the journals, right before we started asking authors to provide their RRIDs, about half the time you could figure out which antibody the authors used. But as soon as we started asking for these RRIDs, remarkably enough, that goes way up to about 90%. And these antibodies, they're a very tricky reagent, and the companies that are involved in making and selling and producing these antibodies or organisms or tools are also very interested in making sure that they know very well, how their stuff is being used, so they can maybe yank it off the shelf if needed, or they can add additional validation data. And so here's one of those companies. It's one you may have heard of, Thermo Fisher Scientific. They're a fairly big company. But what they did is they said, hey, look at our lovely list of 115,000 antibodies. And we're going to make sure that anybody who wants to find a citation can actually find that citation right on our website. And of course, so they really encourage the RRID by using it on their website. So we looked across time, and now this is a study of about 2 million papers. For these antibody-containing papers, there were about 360,000 of these. And we looked all the way back to 1997 and just found the percentage, essentially, of these antibody citations that were associated with a catalog number, which makes them findable again. And it was about 10 to 15% back in the 90s. And you can see that this blue line, this is the overall literature, actually increases to about 25% somewhere in the 2015-2016 time period. And then there's really this nice big deflection towards more identifiability, towards more catalog numbers. And when we looked a little bit deeper at the individual journals, so now you've got a bunch of these individual lines, you can see that there are a few journals, like here, Cell and eLife, that are really driving this inflection. And those journals, what they've done in 2016, both of them came on in 2016, you can see that when they changed their policies and they started to enforce RIDs, they changed from kind of an average journal to 90+% identifiability. The PLOS One instructions to authors also changed, but nobody reads those. So, but certainly there is even a little bump there in 2018, 2019, even in PLOS. Okay, whoops. All right, so what does this actually look like in a paper? So if I were to run across a paper and it had RIDs, how would it look? So here is a method section, a partial method section from this eLife paper. And again, what we have is a bunch of mice. These are all mice, and I know that because of the prefix of the identifier. So this is Jackson Laboratory, and that's the MMRC. So if I click on one of those, through the magic of the internet, I end up magically through the RRID resolver on the mouse strain datasheet, which, by the way, also encourages the use of RRIDs. So it all kind of comes full circle, doesn't it? Okay, but why would I care about this thing? If you know that there are lots and lots of product recalls, even lettuce, which, as far as I can tell, is not barcoded, can be recalled. In fact, it was fairly recently. But does this really happen? Can papers be recalled because of a reagent? Well, not really, but maybe they should be. So this is a relatively recent paper. This is actually a story about a paper that found a couple of really nasty bugs in some Python scripts that were used in hundreds and hundreds of chemistry papers. And essentially, it affected NMR shifts. And the problem was that there were incorrect measurements that were being made, and those depended on the operating system. So this is a very serious problem. And there may be other problems. So again, these Python scripts are listed. They have an RRID, and they have a lovely warning that says, "Hey, by the way, there's a paper. You might want to check this out. There's potentially a problem." Good things are sometimes said about these reagents. So this is that information about each RRID. This is a note that the ENCODE project actually validated this particular antibody. And here's another note, this one actually in red now, that says, "Hey, this is a contaminated cell line." But the question is, do people read these notes? Do they? Yep. They do. So here we found 150,000 papers that did not use RIDs. And then we ran a fairly strict matching algorithm to try and figure out if these cell lines were actually matched one of the cell lines that were listed in the problematic list. And we did that, and we found about 16% of the papers actually were using one of these problematic cell lines. Now, again, some of these are fine to use, but many are not. So when we looked at the 634 papers that were published with cell line RRIDs at the time, it's way more now, but these papers only found, matched 5% of the time. So with no additional editorial oversight, without somebody, beating people's heads in with don't use these contaminated reagents, simply the note there. And by the way, the note wasn't red. This note wasn't red. We recently turned it red to make it more obvious. But during that study, the note wasn't red. It was just all black text. And it seemed like there was a 66% reduction of the use of these naughty cell lines without additional oversight. So really, this is saying that when people have to go into a particular portal, they have to go look up a number, they are paying attention. They are looking at what is stated about those reagents. Okay, but this whole process still is very difficult, right? We still don't have more than about 30,000 papers using RIDs at the moment. And we have been at this for, over 6 years. So can we actually automate addition of RIDs into manuscripts before they're ever published? And so the answer to that came from an automated tool that we've been working on for the last couple of years called SciScore. This is an automated reviewer. It takes as input the methods section of a paper, and it gives as output a set of helpful hints, hopefully helpful hints in the report. It is currently in use in about 12 different journals, where the authors put in the journal submission system, they put in their method section, and they get back a report. And so what this thing does is it actually provides authors with relevant RIDs if the tool can find them, or notes where the RID should be if the tool cannot suggest an RID. Cell line problems, if those are found, it tries to add those right to the report, and it does also turn those red. It turns broken GitHub links and other DOIs that are broken red. It tries to point out clinical trials issues where different database identifiers are actually not proper. So it does all those things, and it helps authors take out some of these problems in the literature. Okay, so AdGene came to us a while back, and AdGene is a big supporter of RIDs with each of these pages of their phages. They have a lovely how to cite this plasmid section, which of course includes the RID. But they said, hey, we spend a huge amount of time actually soliciting plasmid deposits. They have a ton of them, but there are lots more coming out. These things are created by a lot of different labs, and they have to be sent to AdGene to store them and then also to redistribute them. So one of the questions that we got is, hey, can we detect plasmids in the text? And then can we encourage authors to actually deposit those or any of the other reagents that might be used? How can we potentially work either with the journals or work with some tools like SciScore in order to be able to encourage these good behaviors? And I think that the question to that, or the answer to that is, of course, but we don't really know how to best do that at this point. So we're trying to form this working group in order to try and figure out how is it best addressed in the scientific literature process. Okay, so thank you very much for listening. And I would always encourage everyone to use RIDs in everyone's next paper if it is appropriate to do so, or using the IGSNs if you happen to really like rocks. Okay, if you use the IGSNs, we probably will not tweet about it. But if you use an RID, we actually do have a robot Twitter account, which will tweet about your paper, which is kind of just a fun thing that I am now talking about. Okay, thank you very much and have a good day.